So this is going to be an overview of nDisplay. I'm going to take you through the various components, how to get it set up in a project, how to set up a config file, and how to run it on multiple machines. So we do have some documentation already for nDisplay, links in description, but I thought it would be handy to go through some of the core fundamentals of this in video as a real-time demonstration, and show you it working on my PC. So let's talk about, first of all, kind of the main core components of nDisplay. So in order to get nDisplay running in your project, as per the docs, there's a couple of bits we need to do. We need to enable the nDisplay plugin, and that's going to ask you to restart the editor once you've done that. And we need to then enable nDisplay in project settings, and also tick the use borderless windows. Now, the best place to start is to create a new project using our our template. Now that's already got all that stuff done, but that's how you would enable it in an existing project. This is my own custom level that I've created, but the template, as mentioned in the documents, it is a great place to start. And I would say in general with nDisplay, before setting up something huge, just take a single PC or two computers on a network, and get the sample project working, because any issues that you're going to have there, you'll be able to flag back to us. And because you're in a very known environment in the maps that we've set up, in the project that we've set up, it's going to help us debug the very specific issues that you may or may not be having. So I think that's a really great place to start. We'll talk about the implementation of the blueprint side of nDisplay in a moment, but for now, let's just stick with that. We need the nDisplay plugin in a project. Now, nDisplay doesn't work when you hit play. That's not the purpose of nDisplay. That's not what it's designed to do. It runs in two ways, actually. One, as an executable, and two, you can run Unreal Engine in game mode, which I'll show you in a minute, which essentially runs Unreal Engine as if it was an executable, but from the project. And this is really handy for fast iterations without having to repackage the project each time. But to run nDisplay, we don't run it from Unreal Engine. As I said, we run it from some executables, which I'll just go and find. So I'm just going to browse to mine. Yours will probably be in a similar place, but who knows? So this is all relative to your paths. So going into Engine, Binaries, .NET. In here, there's two important files. We need to run the launcher, and we need to run the listener. I tend to find at this stage it's really handy to pin these to the taskbar so I can get them whenever I need them. Now, there's some information in the nDisplay launcher that I've already popped in. I'll show you how to do that in a minute, but let's just talk through what these two things are. So the launcher is essentially the control panel that launches nDisplay, and the listener needs to be running on all the machines that you would expect nDisplay to fire up on. Bear in mind, we're talking about a multi-machine setup here. You only need to run the launcher on for one machine, and It doesn't have to be the master machine. Talk about master machines in a minute, but it's as good a place as any. So I'm just going to run this project so that you can see it running and how that worked, and then I'll remove all this stuff and connect it all up, and I'll show you it running. So just going to hit run, and that's now firing up on my laptop, which I'm recording on, but it's also actually firing up on another machine. And now as I'm moving my Vive puck around, we're getting a perspective shift. And here's really kind of the power of what nDisplay is doing within Unreal Engine. It's shifting the perspective based on a tracking position. Now you could have various different camera tracking systems. I'm just using a Vive puck for now, and I've got a separate video on how to set up Vive if that's what you want to do. But bigger installations are going to use bigger motion capture camera tracking solutions. This is just what I'm using at home, really. So from my perspective, I've just placed the Vive tracker on top of my iPhone. And as you can see, as I'm moving left and right between my two monitors, we're getting the correct perspective mapping. As if we're looking through one single volume. The right display is a completely separate computer to the left display. And in fact, all of the Vive tracking information is traveling over the network in real time as well. So let's clear out these files, and I'll show you how I set that up. Going back to what I said originally with regards to there being two ways in which you can run the nDisplay project from Unreal Engine. The first one is that you can package your project. So under package project, Windows 64-bit, you build that out into an executable. That would result in something that looks a bit like this. And you would fire up the launcher and add that application in. So I will just go here and browse to this executable. Here it is. I would then add my config file. The config file can be anywhere. It's really important to establish that wherever these files are, they all need to be in the same relative path on all the machines. I'll show you how I've got that set up in a second. But storing the config file within the project is a pretty sensible place to put it. So we'll just use this one for now. I don't think this will fire up. I'll try it. I haven't tested this one, so I'm not sure the data is on the other machine, but it might do. So basically, once you've added the executable and your config file, you hit run. Oh, you have to select the executable, you hit run. Looks like it's going to try, and yes, it is running. And actually, I can confirm it is running on the other machine as well. That's how you go from Unreal Engine to an executable into nDisplay. Let me just close that out. And I'm going to remove this, and I'm going to repeat the process for the project that I showed you the first time. But I'm going to do this as in editor game mode. So click on add project in editor -game mode. First thing it's going to ask you is select your UE4 editor. So you need to browse again to the Epic Games installation folder where your engine is. Go into the folder engine, binaries, Windows 64, and then select the editor executable. The next thing it wants to know is where your project is. So again, browse to where your project is, select the file, hit open, and that will give you this path here. Same thing for the config file. talk about config files shortly, but I'm just showing you at the moment you need a config file. And within the same folder, I've got it in the same place. And I'm just going to choose the 2PC one that I've got set up. And then I hit run. Again, forgetting to select that. Hit run, and it'll fire up across the two machines. If that config file, for example, had only one machine in it, then it would only fire up on whatever machine was set up. So let's talk about these paths and how I've got my architecture set up, because I think it's really important. So what's going to happen when you hit run is the listener, as you can see in this dialog here, is going to run some commands. And in order for those commands to be completed, every machine is going to have access to the data that the listener is being told via the launcher and the config file to go and get. So it's really important that the data on all the machines is identical, and there's a couple of ways of doing that. For my small setup at home, I've just simply created a shared drive on my slave machine, and that's got my projects in it, and I'm just literally working out of there. The reason it's on my slave machine is, it can be on any machine. The reason it's on my slave machine is just that's actually where I'm doing most of my work, but I decided to host nDisplay off my laptop. So basically, as long as your machines are able to get to the exact same files based on the Windows file path, this is important. So really, this is just Z nDisplay_template. Everything needs to be the same on all the machines. There's other ways you could do this. If you didn't want to have the project shared over the network like this, you might want to use version control to push and pull synchronized projects over various machines. There's nothing stopping you from using a Google file stream as well. I kind of had experimented with that too. To note, and this is a bug that I found, in order to make sure these paths work, it's best to not have any spaces in the file path. And as you can see, Google adds this My Drive folder that adds a space, and I couldn't change that. So all I did was just shared my projects folder and mapped it as a drive to Z or whatever, and that got me around that issue. Just the reason I was using Google File Stream is it's just a really simple automatic way of synchronizing files across machines. So as I make a change in the project and hit save, it's just going to update it across all the machines. Those machines could be off-site as well, potentially. And if you wanted to, you could use any file syncing solution you'd like, really. But I think it's just important to be aware that the only thing that's really being distributed across nDisplay in terms of networking are the commands to fire up the various machines, the nDisplay nodes, and any keyboard or tracker data that's being passed around that needs to be shared and synchronized across all machines. The actual project is not being shared. It's why it's important that the project is everywhere and with the same file paths. So I probably covered that more than I needed to. So what I will show you next is just in Unreal Engine, what I've got set up in there, because there are some things that are required on the Unreal Engine side for this to fire up beyond the plugin. So within the template, you get this blueprint, and it's got a component that's quite important, and it's called the display cluster root component. I'll just open this blueprint. All of this blueprinting here, if you were interested, is part of the separate Vive tracker tutorial I was talking about. But really, this display cluster root component is what nDisplay is picking up. It is what defines, as you'll see in the config file, the root of where the screen hierarchy is. And it's quite important to be aware of that side of things, because it's going to be where the majority of your work goes getting set up. There are various blueprint actions you can make with nDisplay. It's all in the documentation. There's references to it all. In my case, I'm using some blueprint nodes here to grab some VRPN tracking information and do some stuff with it. Again, it's in a separate tutorial, which I'll link in the description. But really, that's all you need in your scene. And I believe as long as you've got nDisplay plugin enabled, that will automatically, if when run through the launcher, be included. But it doesn't hurt to actually use a blueprint pawn. Or I think it's just an actor in this case. It's actually a display cluster root actor, so it's a specific class. So, config file. I think this is where a lot of people get either a bit turned off or a bit stuck. We are updating the way that you configure nDisplay to be much more user-friendly. But this is what we've got for now. And I think it works. It's robust. It's just not as intuitive, I appreciate, as what people would like. We're working to fix that. And I'm hoping that this bit of the video will help get a few people over the line. So in the documentation, there is an extensive document which takes you through the config file. I think it's really important to go over this or have it referenceable so you can remind yourself. The config file is important because basically what it's telling nDisplay is what environment am I in? Am I on 2 machines with 2 monitors each, with 4 viewports on each monitor, with the camera tracking coming in from a Vicon on this IP address, blah, blah, blah. It's like, it's the instructions that every single machine are going to need to be able to synchronize their setup perspective-wise, off-axis projection-wise, in order to create the illusion that it's all one mapped interactive experience, for example. It ultimately describes the geometry of the screens or the LED wall or the projectors, and it also describes the network hierarchy of your nDisplay nodes, and it describes the inputs to that system, like keyboard and mouse, and where they're coming from. So when you create the nDisplay template project, it does come quite handily with some example config files. I'll just open one of those up for you so you can take a look, and then we'll dive into my specific ones. Oops. So they're in content, example configs, and they're in there. And so if I just open one of these up, you can see that you've got all this text. Now, most of this text is actually quite handily explaining what everything is. You don't need these bits. The important bits are in these square brackets. So for example, here, we've got all of our cluster nodes. In other words, PCs. So you can see that we've got one here called ID. It's called node left. We've got node right, node front, node ceiling, node floor, and they've all got different IP addresses. You'll want to make all your IP addresses across your network static, so they're not changing, because otherwise it's just you're gonna be chasing IP addresses around all the time. That should be something you can set up within Windows. Just set up a preferred IP address. That should, if you just Google that, should be you should get some pretty straightforward answers to that. But one of the cluster nodes is the master, as described by this argument here, and it's also got sound enabled. As I say, all this is described nicely in the documentation as well, but there is also all this instruction kind of description, really, I should say, within the config files itself. So what we have is we've got our cluster nodes, and then the next thing we get on the way down is the application windows. And this describes the window that each machine is going to, the desktop, I should say, that the nDisplay is going to use, and what viewport, and we'll come to viewports in a second, are assigned to those, and whether it's full screen or not, or whether it's specifically using a top left corner of Windows. But we're talking about the desktop. We're talking about the pixels that hit your monitor. So that all gets described here. Slightly different setup you'll see in my config file, but that's that. As you'll start to see with this config file, you'll see that we had window that then was assigned a viewport. And actually, as we go down to viewports now, you can see viewports that those IDs relate here. And this config file is essentially made up of a bunch of parents and children, really, to build up this structure. So the viewports, they are simply the viewport that Unreal Engine is going to map out to the window that you've given it, because of course you could have two viewports from Unreal Engine going out to one monitor or one projector or one LED panel if you wanted. Not that that's particularly normal, but that's what this is here for. It's allowing you to essentially say how much of that. So I've got this window. How much of it do I want to use for Unreal Engine? And actually, you can see here these have got different resolutions in them. So this is where we can define. We can work with different resolutions on this, because obviously if you're using projectors, they could be all different types of projectors. Same with monitors, really. LED walls tend to be built up of the same individual units, but you might have a different LED panel for the ceiling, different resolution, for example, than what's on the walls. And also, as far as the nDisplay is concerned, it's talking to an LED processor anyway, so that LED processor's resolution might be different from another based on how many panels it's handling. And in here, the next thing that gets assigned is the projection, as you can see. So we'll move down to projection policies. Now, projection policies are essentially telling nDisplay, I know what window I'm using on a PC, I know what Unreal Engine viewport is going to render onto what window and where. But what am I looking at? Is it a curved surface? Is it flat? There are basically projection policies that exist that we're implementing. For now, we've got MP, CDI, and Easy Blend. These essentially allow you to configure nDisplay to work with those protocols to allow you to describe a projected surface for projection mapping, for example. But in this case, because we're just using monitors, or if you're using flat LED panels, then simple would be fine. And so we're just taking those names that were defined and assigning them simple. And then again, the next thing that comes up is that we're going to assign that screen, the projection screens. So the screens are, in my case, with monitors, actually the actual monitor. We will need to describe the size of these monitors, in this case it looks like they were 3 by 2, so they're quite big monitors, and we'll, like I say, I'll look at my config file after this in relation to this one. You'll see the difference, but they're obviously working with some decent sized monitors here, and then their parents are the display left and display front, which we'll come to in a bit, because parenting becomes really important in terms of how the hierarchy, I suppose, or how the geometry of your displays is set up. So here's our camera. This is the nDisplay camera, not the camera that you've got in Unreal Engine. This camera is used to calculate the viewing perspective, really. So as you saw in my 2-screen setup, as I was moving the Vive tracker around, the perspective was changing. That's because ultimately what the Vive tracker is doing is moving this camera component. And it's the camera component that's essentially changing the off-axis projection based on where the display root component node is in order to produce the correct perspective on the screen. This is also where we can set up things for stereoscopic projection as well. So the scene nodes, this is where we get into the meat and gravy of how the layout of all the screens or projectors or LED panels, whatever, is set up. And again, this works in a parent fashion. In the documentation, there is quite a handy example. It shows you what all these things show up as. So I think this particular config file doesn't relate to this one. Let me see if I can find the one that relates directly to this. I think this looks about right. So I'll just show you how this relates, because I think once you understand how this text relates to this sort of layout visually, that makes a lot of sense. It's going to help you understand this over here. So here's 6 TV screens, say, in a configuration. They are, by the looks of things, there is the cave origin and then the eye level. Obviously, they're not on the floor. And then there's columns 1, 2, and 3, which you can see here. And then you can also see that there's these angles as well. Now these are arbitrary. You can call these, you can call pretty much anything that's not in square brackets, whatever you like. I mean, obviously there's some of this text you need, but what you call things is actually up to you. But obviously keep it pretty logical. But in here, essentially what is happening is that there is the top level parent is the cave origin. That's going to be the center of wherever your tracking system is, wherever you want the cave or the stage origin to be. I think it's really important you have a stage origin. In this case, the eye level is used to move essentially all of the columns and displays up, and then column 2 has got 2 displays in it. Then there's an angle, which could be used to dial in the rotational angle of one display to another, one set of displays to another. For example, if this was a curved set of screens rather than flat. And yeah, as you can see, it's repeating itself, but essentially we're using these separate scene transforms to, with text, describe the geometry of screens. How does that look in the config file? Well, here's our cave origin, which has got no parent. Now, when it's got no parent, the default is the root of the virtual reality tracking system that you've got, or the display cluster root node. So as you can see, the next level down, we've got this scene node called eye level. That's just been left at 0 in this particular document, but you can see its parent is cave origin, and from now on you'll see the word parent at the end of all of them, and that will essentially is what's putting them into this parental hierarchy here. So column 2, for example, is 1 meter in X away from the eye level. So essentially in this case, it's 1 meter away from the origin. And then display 2, and display 2 up and display 2 down are the 2 children of column 2. And as you can see, one of them is above column 2 by 0.155, and one of them is below column 2 by minus 0.155. And what is that? This number? Well, it's half of the height of these screens. And if we look further up in the config file for these screens, let's just skip that, didn't I? We can see that they are 0.3 in height. They're 30 centimeters high. Well, 0.155 is obviously not half of 0.3, it's more than half. And the reason for that is to create a 5 centimeter gap between these screens, or in this case, it would be a 10 centimeter gap because they both got this offset. So that's what's essentially moving the center of this display from being here. Otherwise, this display 2 up would be here. That's what's moving display 2 up to there. And then we got an angle. Now this angle is its parent is eye level. So again, it's 1 up from the eye level and the origin. I don't know why eye level and origin are the same. In this case, it's pretty useless, but you know, it's still a parent, so it's still relative to it. So the angle is 1 up, but you'll also see it's across in Y by 0.255, which is what's moving it to here. And you'll also notice that it actually hasn't got any rotation. This is pitch, yaw, and roll. In this case, there is no rotation, and as you can see in this diagram, it's flat. Now, if these outside screens were to come round by 30 degrees, for example, so it was 30 degrees, so you had a screen, screens, then this is where we would put in 30. This is in degrees. So angle display 1 would be minus 30, for example, and angle of display of the angle of angle 3 would be plus 30, and that's what would create that, you know, pseudo curved set of screens. But in this case, it's nice and flat. Angle 3 is, as I said, to the left by minus 0.255. Again, if you remember, the size of the screen was half a meter, and half a meter is 0.25, and there's an extra 5 centimeters tacked on to create this gap. And then column 1, as you can see, again is another half screen width away, and then column 1 again has got a screen above it and below it. And then we do the exact same thing again with the angle 3, except for it's plus half a screen width away. Column 3 is again plus another half screen width away, plus 5 centimeters, and then again has got a display above it and below it. These sockets here are for things that you may want to have as wands or interactive elements in a cave, for example. They're not really described in this document, but they're probably a hangover from something else. So that's how we describe the broad geometry. Down next, we've got a list of input devices. Now, just a note on input devices, Unreal Engine will automatically synchronize via nDisplay the pawn input movements that would come in. So that's fine. In my config file, you'll see where I've specifically got some VRPN tracking coming in. We'll talk about that in a sec. So we've got the synchronization policy. This is to do with how we are synchronizing the rendering of the individual panels. To note, if you want to be synchronizing Genlock across multiple screens, which I think is very important for virtual production, for example, you're going to need Quadro cards and NVIDIA Sync cards, and you're going to need to Genlock the system. There's some network settings here. You won't necessarily, if you're doing a simple setup, need to worry about this. Again, all documented. And then if you want to create your own custom arguments, you can do it down here. So let's go and look at my config file for the demo that I showed you at the beginning. And I'm in the wrong place. There we go. Now, as you can see, I've cut out all of the explanation bits, all descriptions, because it's just easy for me to see it all in one place. But there's also a bunch of stuff in here that I've just kept, because this is still just me basing my config file off of an existing one. And I think that's what's quite useful about using the template first and getting that working as a kind of a technical proof, and then evolving from that. And rather than writing a config file from scratch, like edit one, customize it for you and do it bit by bit. So let's start at the top to remind ourselves. We've got two machines. One's the master, one's the slave, called node 1, node 2. And in the we've got two windows there. For whatever reason, I've ended up with a config file that didn't do full screen, but did specify the resolution, even though the resolution is my full screen res. But they're the desktop windows that we're using. We're just using the main desktop of each machine. And my viewports match. And my projection is simple. And there are two screens, which are, and I measured these pretty accurately, as accurately as I could. 59.5 centimeters in height and 59.5 centimeters in width and 35 centimeters in height. Next one down is our camera. That was as it was. And then here's my scene hierarchy. Again, working from that previous one. I've got my cave origin, which is basically a spot on my desk where the SteamVR head calibration was told was the center of the VR space. And I've got an eye level, which is 0.285 meters above that point, which is essentially from here, the center of my monitor. It just means we don't have to do any further height increases because my two monitors are essentially next to each other. Then we've got column 1, which is in front of the VR origin by 60 centimeters. Low rotations, it's nice and flat against the wall. And then I've got display 1, which is at the center of column 1. Then I've got angle. There's an angle node, which I've moved half a monitor's width away to the right and is rotated 35 degrees because I've basically got my monitors set up, at an angle. Then there's another display, which is essentially another half monitor's width apart. You'll see that there is some difference between this being more than double. It's just to count for the bevel width of my monitors. It's just what worked for me. Again, you're just going to need to tinker until you get it right. I may not even have it right, but it looks correct, and that was good enough for me for this sort of setup test. And obviously that display's parent is the angle, and that's what's creating the offset of the two displays. Interestingly, in Unreal Engine, you can actually visualize to some degree what your config looks like. So if you grab the root cluster node, you go down, you will see you can tick this box that says show projection screens, and if you put in the correct file name, which easier said than done sometimes, basically this is the relative file path of your config file, and then you hit play, you can now see the two screens that I've got set up. Apologies for this slight awkwardness. It's just the way I've got my current nDisplay set up with the root cluster being pushed so far away. Gets fixed by the Vive system, but ultimately you can see those two red 2D planes representing my two monitors quite accurately. That's a nice quick way of you seeing whether you've got things right. So for example, if I just come over here and edit this angle to be 0, hit escape and hit play again, you can now see that I've made a very quick change, and you can see that these are now level with each other. Nice. So conversely, if we was to put in 90 degrees here, save, Alt P, stop, and then play, you can see that we've got a nice harsh 90-degree angle now. Well, it doesn't look 90 degrees, but it's just relative to the perspective we've got based on where the cluster root node gets pushed by the config file at the moment. So that's that. It's very handy. I'm just going to change that back to 35 because that's what worked. Next down, I mentioned about inputs. Here's where my Vive VRPN tracker is coming in. In my previous tutorial, I showed this as basically just being listed as localhost, which is a Windows networking based way of saying this machine. That won't work over a network. You need to put in the IP address of the machine that's running the VRPN server, which happens to be 101 in my case. And here's the port number. Leave that alone. Keep it as it is. Make sure that that port is open on your network. It should be. Everything else I've kept the same. So that's how that's running. That's how I've configured my nDisplay. I'm going to save that. So in summary, you've got your listener that you need to run on all the machines. You've got your launcher that you need to launch the nDisplay, either packaged Unreal Engine projects or a project added to the launcher along with the editor you want to run it with via the add project in editor-game mode. And you have your config file, which describes the layout of your screens, etc. You can find the launcher and the listener in the installation folder of your editor. Again, I'll link to the docs so you can go over this in detail and recreate these steps with the tutorial that's in the documentation. And then you would run from here with it selected, of course. And that's just, again, that's fired up on both my machines. And for some reason, the tracker's got lost. I think it fell asleep. But yeah, that's how we're firing up. I think that's it. So hopefully that's useful. Let us know if not, and keep asking questions, and we'll do our best to assist.